Okay. Okay, see it on YouTube.
Okay, I found a video link. Live stream offline. Is it showing up yet for you?
Yeah, it's showing up, and I heard my voice, and I hear your voice.
Okay, let's see how much latency there is. Okay, I'm gonna type something in a sec, and then you can count until it shows up, okay?
Okay.
Right, typing.
Okay, I don't see where it typed. Okay, I'm gonna try something. I'm gonna look at my clock. It says 45 right now. Okay, so when I said now, it was 45. So then,
Oh, I was on the wrong stream. I made other streams that aren't public and are not the one I'm streaming on. That's why it didn't show up.
okay, it's about a 10 or 8 second delay.
That's why it didn't show up.
Okay, it's about a 10 or 8 second delay.
That's why it didn't show up. Okay, it looks like it's working.
$25.
Okay, well, we'll see how it goes. Um, okay, first thing is figuring out what to do. So,
Okay. Wait, I don't actually see where the text thing for Zoom is.
next thing for Zoom, like you want to type on my screen or what?
I just thought there might be chat messages.
Oh, there's chat.
Okay. I don't have like normal overlay for it open, I think, because screen share for some reason.
Oh, yeah, that would explain that. Okay, how do I make you louder?
I could try increasing my microphone volume. Let me see
Okay.
what. It would just be like increasing gain or something. I don't really know what that means.
Yeah, that
Music.
sounds right.
I need
Do
to.
they really not have a way for me to just increase your volume like you can do on Discord? 'Cause so far I haven't found it. Audio settings. Yeah, I can control my mic and I can control my sound. Oh, my sound's like in the middle. Maybe I just need to raise it. Talk?
I am talking right now. I am saying
Okay,
things.
volume's way better. My computer was
Okay.
just too low.
Okay, so it's fine now. I don't need to change anything, or I should still try to change it.
I think it's okay.
Okay.
Okay, so goals. Do you have anything in mind? Or should we just do some of my stuff like trees?
Uh, I don't know. The original thing I was thinking that was going to happen was we were going to do a tutoring thing that would be something involving trees. Yeah, I was thinking I was going to have to open Xmind.
Okay. So some options include that we started in the past would be to review and then continue with arithmetic trees, grammar trees, conceptual trees, or the grammar article.
Yeah. Okay, that's the things you could do, yeah.
And then here's some we didn't start in the past, I think.
Okay, things. I'd like to do arithmetic trees. I remember doing those. I had fun with those. Those are like ones
Okay.
which I haven't like even thought about in a while. Where like sometimes I do think about grammar trees, but not much.
Okay, let's do one conceptual tree first to make sure you know what I mean.
Okay. I have. Okay. This is read on. Okay, that's good.
I just see your desktop, by the way. I don't know if you opened anything.
Okay, I opened Xmind. I need to move
Oh,
things
there it
to
is. It
my
just showed
other
up.
monitor. Yeah. Okay. So this is. Huh.
Okay, make a node
Where?
for Walmart.
Oh. Okay. Can I do? Yeah. And then can you put children on this? Yes, they go sideways. I'll just start with this one. Does adding a new one here makes it go sideways for some reason. Okay,
You can
this will be
drag it
Walmart.
down or change the orientation somehow.
I think it's in format. Oh yeah. So if you
I think the structure one at the top was it.
yeah, then kind of weird. Okay.
Walmart's 1L.
Mm,
It's
wait,
not
what?
spelled like the word wall.
Oh, 1L. Oh,
Okay, so a conceptual tree, you can take something and figure out the parts of it. So you can come up with what would some children of Walmart be. There's many
uh,
right answers, but you can come up with one way to divide it into pieces.
okay. So United States government, you can do like executive, judicial, and legislative. I think those
Yep,
are like three pieces. It's easy.
yep, that's a
So
standard division.
okay, so I'm just gonna start writing things which seems like Walmart might have. Like corporate. Uh, I feel like everything would sort of be under corporate. I'm not sure what things are. I'm just gonna start writing them, even if they kind of are inaccurate. Uh, employees. Like, yeah. Uh, okay, what's something else? They have buildings.
Yep,
Uh, okay. And then, like, maybe corporate has, like, advertisements, HR, like, CEO stuff. I don't know.
yep,
And it's like, although, like, greeters, cashiers, like, might kind of be interchangeable. Like, they do the same
yep.
job
Doesn't
sometimes.
matter too much either way.
Um, mm, like, delivery is all. Okay, just one more
Yep, good
because you
enough.
can do
You
a lot.
clearly got the idea. Okay, and then you can also go the other direction. So can you make siblings and a parent for Walmart?
Okay, so businesses. And let's do well, this on Target.
Mm-hmm.
You just copy paste this.
Oh yes, you can make the tree have more nesting if you want to. On a related note, did you see this?
Where do I find what you are referring to on the
It
screen.
will show up in 5 seconds or 10.
Okay.
I posted this on the forum the other day.
Oh, I did not see this.
It is a tree of trees.
Hmm.
It is a paragraph tree, but then instead of the sentences like normal, it is sentence trees.
Okay.
It took a
Paragraph
while.
tree. Sen-
Here's a normal paragraph tree,
Okay.
where each of the boxes is one of the sentences, and the aqua text is the relationships.
Smooth sentences, awkward text, relationships.
Did it show
Okay.
up yet?
Yeah. So I see the top tree is saying something, and then the bottom right thing is evidence proof. So I guess uh like there's or middle right. So the very top sentence is saying something, and then the middle
Yep.
right sentence is proof or evidence of that thing.
Yep. Okay, so the big tree is the exact same tree, except instead of every box, I put the grammar tree for that sentence.
Okay, so instead of the box, it's the grammar tree. Okay, so that makes it like take up even more space, kind of.
Yep.
Okay, now this makes more sense and is easier to read.
Yep. So that is somewhat related because you were copy pasting a tree into another place and having kind of a tree with trees in it.
I don't exactly see how it's related.
Well, so mine has a tree with trees in it,
Okay, a tree with trees in it.
and you were making a tree with trees in it because you were taking your like lower down subtree and putting it in multiple places
I was.
when you put it under target as well.
Yeah.
Then it's like you have a high level tree of businesses, and then for each one you put the individual business tree, and then you got like a big tree.
And
Oh,
so
okay.
you can minimize this.
Yep. Okay, so that is the general idea of trees. Seems like you remember that you can go to higher or lower level concepts and zoom in or out in either direction.
Yeah, either direction.
Okay, so,
Yeah.
so you want to do arithmetic?
Okay, yeah. I might want to open a tree, which I once did, which I liked. It was just doing coin flips. I don't know if I've ever opened it on Tree before.
Okay.
Okay, so this is a tree of coin flips. How many places did I go? One coin, two coin,
Oh,
three,
yeah.
4, 5. Okay, I went to 5 uh, places. So that would be 2 to the power of 5. I think that's 32. Okay, so if
Yep.
I highlight all these, it should be 32 selected. Yeah,
Oh, it
32.
tells you at the bottom. That's nice.
Okay, so yeah, I made a tree. So like first, you just like have the coin, I guess. You just like start with that node, and then you can either do a heads or a tails, and you flip it. And then in either of those categories, it's now a 50-50 chance that you'll either get a heads or a tails. And then, so if you do tails and then tails again, and you are gonna flip again, you can get either heads or tails. And I think this more clearly shows how it's a only 50% chance, like each individual flip. Like when you're at the very beginning, it's like a 1 in 32 chance that you'll fall in any of these individual patterns. Like you can do
Yep.
like a heads, tails, heads, tails, heads, tail. I guess heads, tails, heads, tails, heads. Uh,
Yep, there are 32 complete paths from the start to one of the end points.
yeah, and there's more notable paths, which are like tails, 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 tails. So like if someone got like 5 tails in a row, like 10 times, then that's probably rigged. But uh, if they were to do like some like less efficient looking one, like tails, tails, heads, heads, tails, then like maybe not rigged. But there's like any combination that could happen. Yeah. Well, if they did that same pattern like 5 times in a row, then that probably is rigged. Oh yeah, so I was able to make this with tree. Very happy.
Yep. Okay, so you can make a tree of a math problem, like 2 plus 3 plus 4.
Okay. Okay. I still remember something about okay, something to do with Polish notations and S expressions and infix or prefix notation. So this is just gonna be like problem, and then it's gonna like have the tree here. It will be a plus. So we do the plus operation on 2, 3, and a 4. Uh, and be 5, then 1 less than 5, so that's 9.
Yep. Okay, what about um
You made more tree.
yeah. For yours you gotta be careful because of order of operations. Like that's gonna be 2 times 2, and then you add the 3, and then you add the 4.
Oh, okay, I'm confused. So this is, then you add the 3.
The multiplication is done before the addition. What
Multiplication.
you want, I think,
Oh,
is this. You can use the parentheses to group together the addition so they get done first.
okay. So with this, there's 2 and the 2. Okay, so with this, to make it more clear what's happening, I would have done for, okay, so without putting any parentheses in it, this is like sort of the operation I would have done. Like I multiply the
Yeah.
2 and the 2. Like this is even without parentheses. The parentheses are redundant, I think.
Yeah.
It just emphasizes what I was doing. Okay. Yes, that was 4 times 7. So what's 4 times 7? I forgot that one. I think it's 42. It's 14 times 2. That's 28.
Yeah.
42 is 7 times 6. Okay. I'm gonna try doing this one right then. Okay, so plus operation, which involves a 2 and a 2, and then a 4. The times operation. Oh, so I think times was actually a child of plus then. Okay, so we add the multiplication with 3 and 4.
Yep. Yeah, the
I
things
tried.
towards the bottom tend to be done first, and the things at the top tend to be done last.
Hmm, things. Okay.
Okay, so I put another one with a 7.
Okay. No. Okay. Mm, okay. So uh, base, and then you subtract from it 3 plus 1. So I'm not sure how subtraction works with prefix notation. I think this is what this is. Like you write it as an S expression or something. I think that's prefix notation. Is that right?
Yeah.
Okay. Not sure how it works with uh
Well, you have
subtraction when there's
a
more than 3
subtraction.
things.
You're gonna have 2 nodes. The thing that you start with, and then the thing you subtract from it on the right.
So can it only have 2 nodes?
Um, it depends how you define it. You could define it so you start with the thing on the left, and then you subtract all the rest of the nodes.
Hmm.
That would be a way to define it with more nodes.
Okay. But with 2 nodes it should be unambiguous.
Yep.
Okay. No. Mm-hmm.
Yep. And what does that equal?
This goes to 4. Then we have 7, we take out 4, so that's 3.
Yep. Okay, so we can do something a bit more complicated. Let's see. How about that?
It's almost written. Okay. Oh yeah, by the way, there's one thing I remember talking about with you where I think I was trying to solve like S expressions, like you were writing S expressions, and I was trying to uh, make them into a tree, and I was starting from like the right to the left, and then you're like, oh, by the way, you can actually do it from left to right, and I don't know how that worked, and I don't know how relevant that is to being able to write these easier.
Okay. Well, do this one first, and then we'll try some different types.
Okay, so uh, okay, so it's going to be multiplication, and then it will be with a 2 and an 8. And then that multiplication will be the first thing in subtraction. I don't know the difference between a numerator and a denominator. One of them does something. Wait, is that for division? Yeah, I think so. Okay. We have you hid the math.
Oh, there. You should copy paste it. Oh, you can't copy paste it.
Uh,
There.
ah, okay. Then around the subtraction, which is that thing Okay. Okay. Okay, so do the 2 times 8, and then it's okay. Okay, so I think we're doing multiplication, subtract 3, and then that is being added into the 4. I'm not sure if
Just
we're
a
doing 3 plus
second.
4 or multiplication minus 3.
Okay, the order of operations is multiplication and division before subtraction or addition.
So I should have tried doing this division first to make things. Uh, okay. Uh, so I think this is just 4 divided by 2, and then you can put the other things into that. Yeah. Okay, so what kind of doing this case? Division. Okay, so I think these 2 plus symbols turn into 1 plus symbol in the tree.
It doesn't matter if you have extra pluses,
Uh,
but yeah, you can combine if you want to. Not a problem.
okay.
Hold on. Okay, so there's a problem with the tree. I
Hmm.
think you have a confusion about how Infix order of operations works. So the minus means that you're supposed to subtract 3.
So
It doesn't mean you're supposed to subtract all the stuff after it. You're only supposed to subtract 3. The next things have pluses in front of them, they're supposed to be added.
Okay.
Does that make sense?
Uh,
Like,
okay, so I
so if we
don't
have like
add
1 plus 5 minus 3 plus 2,
1 plus.
you know what this equals?
I'll see it soon. At a glance, I don't. I need to try to solve it.
Okay.
So I think the 1 plus 5 makes a 6.
Yep.
And we subtract 3, which makes a 3.
Yep.
And we add 2, which makes a 5.
Yep. So the important thing is the 2 got added, not subtracted. You didn't like add these together and then subtract 5. The minus only applied to the 3.
Okay. So
it works the same way in the other one, where the minus only applies to one thing.
plus minus by
If there's a multiplication or a division after the minus, then that gets done first, so then the minus could apply to multiple things. Like if you had 5 minus 2.
okay. Okay, so I think that one would be right. Still writing. Okay, so I think the 5 minus 2 times 2 plus 1. Uh, okay, so I think you do 2 times 2 to get 4. Then you
Yep.
do 5 minus 4 to get 1. And then you do plus 1 to get 2.
Yep. Yes.
Okay. Okay, so for this, we do 2 times 8 to get 16. Then it's 16 minus 3 to get 13. Then we have
Yep.
well, then it would be 13 plus the result of this division.
Yep.
So I don't think the division, yeah, we do the division, which like basically removes the division symbol. So we can't have added a 1 to the division. So it's the plus, uh, okay, so 13 plus 2 plus 1.
Yep.
Okay. So minus 3. Okay. So then we did the multiplication on it. Then we did the subtraction on it. And then after that, it gets added to the division. So that means here. It's added to the division and 1. Okay, so I think this is the right tree. Okay.
Yeah, that looks good.
Okay, so 16. Did it equal 16 when I read it though? Okay, 16, 13, 2. Oh yeah. Okay. I did not know roots were a or What was I going to say? Roots sound like the exact opposite of exponents. Uh,
Yes.
if you do something to the power of 10, and then you do that result to the root of 10, then that gets you to the exact same thing. Like if you have, say, 2 to the power of 2, it gets you to 4. And then if you have the square root of 4, that is what you need to multiply by itself to get 4, you would go back to 2.
Yes.
Okay, so it kind of works exactly like multiplication and division. If you multiply by 10, then you can
Yep.
divide by 10 to get back.
Yep. And then addition and subtraction are a similar pair.
It seems less similar to me, but I see how if you do add 10 to something, then you can remove the 10 to get back to the original.
Yep.
But it just intuitively feels less of a pair for some reason.
Okay, so I made a tree, and you can try to make a math statement from the tree. You can translate the opposite direction.
Uh, okay. I think it would be easier to make it an S expression. Yeah, I'm gonna make the normal writing though. Okay. Typing. Okay. Okay, so there's a tree. What am I trying to do with the tree? I'm trying to turn the tree into writing. Okay, that sounds difficult. So what if I tried to turn this tree into writing to start with? So what is this supposed to be? I don't know. I forgot what this tree is. It has to be addition because it equals 4. Okay, so I'm going to try to turn this one into writing because that seems easier than turning your one into writing to start with. Okay. Well, it's gonna be a 3 and a 1. Okay, so we're adding a 3 and a 1. This is definitely part of it. Uh, and then we're going to subtract the 4 from a 7. Okay, I think I turned this tree into this writing. Okay, and this one. Okay, so now yours is
Hold on.
well,
So if you do 7 minus 3 plus 1, what result do you get?
oh, you'd get a 4, and then you add that 1 and you get a 5.
Uh-huh. And what does the tree say the result is?
Uh, says you get a 3 instead of a 5.
Yeah, so something is different between the two things.
Okay, an easy fix to this would be this, but I don't know if that's actually how you're supposed to do it. I don't think it is.
Well, if you do that, what you're saying is to do the addition first, right?
So are you saying I could, uh, yes, this is what you're saying, to do the addition first.
And is that what the tree says to do?
Yes.
Yeah, so that's correct. In the
Okay.
tree, the thing being subtracted is a group. It is a whole subtree instead of a single number. So using the parentheses makes it subtract the group.
Is there a way to do this without the parentheses, or do you have to use parentheses sometimes for the trees?
I think you need parentheses for that. I mean, there's other things you could do like variables. So you could write x equals 3 plus 1, and then you could do 7 minus x. So you don't need parentheses because the variables can do grouping for you.
Huh. Okay, so the variable is a group, so I could like turn the 3, or I could define 3 plus 1 as x. And then, so, okay, yeah, so it like turns into the group itself, or, okay, so variable can turn into the group instead of having to like make the group every time. Okay. So what am I doing now? I am trying to make the big tree.
This one.
Yes.
All right. Make it show up easy.
Okay. So uh you're going to have a plus symbol. This maybe shouldn't be in Markdown. Okay. Then what do okay. I'm gonna start with one of the subtrees because I'm getting intimidated by starting at the top. Okay.
Okay.
The minus one. Okay, so that's gonna be a 4 minus 1. Okay, that's very easy. I'm just gonna add parentheses around that for now.
Yeah, you can add lots of extra parentheses if you want. They're pretty harmless.
Okay, so that is a group in itself. And then I'm gonna use down to mean right. I don't know if that will actually matter, but that's what I'm gonna try to have it as. Okay, and then we did a uh, multiplication. What did we multiply? Okay, so it's basically multiplying 3, but okay, so it's multiplying an addition. So that addition is 1 plus 2. Okay, and 3. That's okay, so that was the multiplication one, which included the addition one. Okay, then we go to this division one. Okay, so we have a 9. Uh, 9. Okay, I'm typing 9 with the wrong finger. Okay,
You
9.
deleted your 3 on the previous line.
Oh man. Uh, I was typing 0 and 9 with the wrong fingers, so I tried to uh, retrain that, but I guess it's not actually fully
Accurate.
habitual. Yeah, so sometimes I just do the old habit instead of the new habit. Uh, okay, so what is this tree? What am I on? I'm on the division. Okay, so what are we dividing? We have a
Is
9
9 supposed to
and
be your index finger and 0 your pinky?
yes.
Yeah, that's not my habit.
Oh.
I think I type them both with my middle finger.
Hmm.
Maybe the ring finger for 0. If I want to type numbers fast, I use the numpad anyway.
Mm-hmm. Okay. So division. We're dividing 9 by a minus, which the minus is going to be grouped with parentheses, and minus will be 3 minus 1, which is a 2. Okay, so divided 9 by 2. Awesome. Okay, and then we have a 3 and a 10. Okay. And then it's gonna do. Oops. Plus. Okay, and then plus. Okay, and then oh hey, this is looking like it. Okay, so, go to there. Yeah, I think I go to there. Okay. And then we do. I'm just gonna add a parentheses here to be safe. We don't think any harm can come from that.
Yep, it is perfectly harmless.
I think I did it. Okay, so let's see. We do 3 plus this operation. In the tree, we did yeah. Okay, then we did the 3 operation. Then we did yeah, the 3 and the minus plus a multiplication. So here's a multiplication. Yeah, we're multiplying, or we're adding the multiplication. Cool. Then after the multiplication, we add a division. So you need to have an addition symbol here.
Yep.
Okay, so we're adding the division. So I'm just going to trust that the division is right. And I see that, yeah, we're adding the division. Okay, and then after that, we add the 10. Okay, I think it wrote out properly.
Okay, cool. Can you solve it?
Okay, I'm not sure which one to solve. I feel like I have 3 things which I can try to solve. The tree, this, and this. I think I'm just going to try solving this.
Sure.
Okay, so we
They should
have...
all give the same answer, so you can solve any of them.
Yeah, but I was thinking that one might be easier than the other. I feel like this is the hardest to solve, but this should be fine. Okay, so we have a 3 plus 3 basically. No, literally, it equals 3. So, by definition, it sort of is 3. I don't know.
Yeah, I think the infix math is the hardest one to solve, but our culture is so used to it and teaches it in school that it looks normal to people.
Okay, it sounds like this is some philosophy stuff about things that we commonly do bad in culture. Is that right?
Yeah,
Oh, that's interesting. I didn't know Infix math was uh, maybe bad. And in that, like, I forget what it is. Prefix was pretty fun. It was cool using prefix. Like, you can just do the plus operation and then, like, whatever you want, and then just, like, send
yeah.
it.
Infix has a few problems. One is that plus only takes 2 things instead of however many you want. Another is that it requires order of operations, whereas prefix and postfix don't require order of operations.
Is postfix reverse Polish notation?
Yes.
Okay. Okay, so we got to that part. Actually, I'm gonna. Okay, so we got to this part. I can use one of those. Sure. Okay, and then we add. Okay, so this is 3 times 3, so we add a 9. Okay, 3 times 3, so we add a 9. Okay. Uh, then this is a division. Okay, and this is a 2 divided by 9. So that's gonna be 4.5. Yeah, you can. Okay, so how many times does 2 go into 9? It goes into 8 4 times, and then 2 goes into 1 half time. It's 4.5. Yep, yep. Okay, and then we do 10. Okay. Okay, now what do I do with this one? Okay, so we get a 6 plus 9 is a 15. 15 plus 10 is 25. And then it's 29.5. Okay. If I just throw this into a calculator, does it agree with me? Yes, the calculator agreed with me.
Okay. Any questions, or does that all make sense?
Okay, does anything here not make sense? I mean, these are groups, so you can just do the groups, like this 9 is actually somewhere in here. It would be the second one, so it would be the third one. 2, 3, so it would be this multiplication. Okay, so this is the multiplication group, then that group is the subgroup of the unaddition group. So this 9 actually, okay, how do I select multiple different things? Okay, select, and then multiplication group. Okay, so these are the same thing.
Yep.
This 9 is just a simplified multiplication group. I think this makes sense to me. Yeah,
Yep.
because you have the group of the addition, and before you do this addition, you actually have to do this. Wait, you have this group of the multiplication. Before you do the multiplication, you have to do an addition. Then once you do the addition, it's just 3 times 3. Yep. And then that equals 9, which equals is an interesting concept that does not mean solve the previous equation, which is kind of what I thought it meant for a while, but it really means like it's the same math.
Yes. And when you solve an equation, the answer is the same as the equation.
Mhm.
They're worth the same amount.
Yeah, so it's like
So
kind of
they are
interesting.
equal when you get the right answer.
Yeah. So that's a cool thing about equations is that it means they're sort of just interchangeable. Like you could change out the group of 4 for the group of 1 plus 1 plus 1 plus 1.
Yep.
And it would work out perfectly fine.
Yes, that is called substitution when you substitute things that are equal.
Oh.
It is commonly done with variables. For example, on my screen where you see that x equals 3 plus 1, you can, and then you see 7 minus x equals question mark. You can substitute the 3 plus 1 for the x because 3 plus 1 and x are equal. We know they're equal, so we can put this here.
Yeah.
And then we got 7 minus 3 plus 1 equals. When you do a substitution, you can put parentheses around it to be safe, because it's supposed to be a group.
Jesus. Yeah. Okay, that makes sense. And so there's not like any harm. Like if I say do like 5 plus so if I just like what did I just do? Okay, so I do like I use control instead of shift. Okay. So if I just keep adding parentheses, say, I don't think this harms anything, right?
Right, it is a group that consists of 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 5
Okay,
plus 3.
these went the wrong way. Okay, so I'm just gonna do. Okay, and if yeah, so nothing wrong can happen from this, even though it's a lot of redundant parentheses, I think.
Yeah,
But
that's fine.
nothing bad can happen.
Yeah, it's just, it is a group with one thing in it, which is a group
Okay,
with one thing in it, which
a
is a
group.
group with one, and so on and so on and so on until
Okay,
you
so
get to
this group
5
has
plus
a
3.
group. This group has a group. This group. This group has a group. Has a group. Has a group. Wait, no, this isn't a group anymore. This is the group of 5 and 3. I was gonna say that this contains the plus group, but I think this is just the whole group. Yeah, I don't know. Okay. Yeah, nothing bad can happen. Okay, that's good.
Okay, I'm going to do the tree quickly. So, one way to do it is you see, okay, we're adding things. So we have 3 plus some group plus some group plus some group plus 10. And then we can fill in what the groups are. So this group is 4 minus 1. This group, second group is multiply. We have a group multiplied by 3. And then we can fill in the group, which is 1 plus 2.
Okay, this makes a
wrong
lot of
place.
sense. Starting with the groups. Like, they don't know what the groups are, but you know they are something, so you can just
Yep, and
make
this
the
other one
group.
is going to be 9 divided by a group, and then we can figure out what the group is. And it is 3 minus 1. So that is one way to do it. It's not the only way. You could start at the bottom, but if you want to start at the top, you can just not fill in the groups immediately.
Yeah. So I guess I filled in the groups immediately, but I did make them into groups, even if I maybe didn't fully realize it. Like I had separate lines for like each group, I think.
Yeah, that worked
Like
out.
each child node of the
We were
addition.
adding 5 things, and you figured out what they were one by one.
Okay. Oh yeah, there
Okay,
was the math thing, or like what was the math thing? Oh yeah, I once saw a math thing where it had two unknown variables that you had to figure out, and it had two equations, and I didn't know how to figure it out. Could we do that on the stream right now?
okay.
Okay, let me try to find it. I'm gonna stop sharing while I try to find where it is. Because I saved it, but I don't actually know where I saved it. So maybe I shouldn't actually have done this right now.
Can you just look for it on your second monitor?
Uh, yes, but I want to pause the screen share in case I open something in the wrong screen.
Oh yeah,
Because I
okay.
don't know how Windows works. Yes, like right then it just shared something on the wrong screen.
Did you pause? I still see it.
I did pause. Did you see the image that was shared?
No,
Okay, that's good.
no, I'm just seeing. I see our math though. Like you didn't end it. I didn't know there
Yeah.
was a pause button. That makes sense.
Hmm. Okay.
Okay, I can't have 2 reactions. Try delete a reaction. Oh, it went away. Maybe they just last a short time.
Okay, I found the math thing. Uh, okay, so it is this thing. Someone shared it on a Discord that I was in as a part of like being like, what the fuck is wrong with the education system? But I didn't know how the math worked. So that was the kind of thing I was interested in was the math.
Okay, so problem 3 or problem 5?
Both of them. I didn't understand either of them.
Okay, so we'll start with number 3.
Okay. Hmm. Yeah.
Okay,
So
so the
I
basic
guess we can.
concepts that you need here are to understand what an equal sign means and to understand substitution, where you take 2 things that are equal and you can swap one for the other one.
Okay. So equal. Okay. So instead of an x plus 2, so if x was like 10, or x could be 10 plus 2, so y could be 12. So that means whenever you write x plus 2, you could instead write y. Does that make sense?
Yeah, wherever you see an x plus 2, you could replace it with y because they're equal.
Okay.
And it works in the opposite direction too. Wherever you see a y, you could replace it with x plus 2.
Replace x plus 2. Okay, wherever you see a y, you can replace it with x plus 2, and wherever you see a x plus 2, you can replace it with a y.
Yep.
Okay.
And wherever you see a 12, you can replace it with a 3x plus 6y, and vice versa.
12, 3, x. Okay, I've only actually read this line so far, so I was a bit confused by the 12 thing.
Oh, okay.
Okay, I think I'm gonna write this out, so it's easier to solve.
Yep.
Okay, x plus 2.
Oh, I'm starting to read the text. I'm wondering if this got shared because people are like, why are they giving kids these examples?
Uh, yeah, I'm not.
Does
So
she work as a bookie, drug dealer, or nightclub dancer? What? And what does that have to do with math?
Yeah, it was kind of confusing. And like I don't see how these numbers like actually like
So
solve for
I
it.
believe that the first one is what x is, and the second one is what y is.
I guess the first.
So the first idea is that maybe x is 0 and y is 2.
Oh yeah, I have actually gone through this once, and I tried to like replace the y's and the x with like the zeros and the twos, and it worked out when I had the 0 as the y and the 2 as the x. I like think that's what I did, but I like didn't understand like mathematically like how to do it. I just like sort of
Yeah.
did it through brute force, and they already gave me the suggestions of what to try. Uh,
Wait, this
but it like
actually makes no sense. The numbers have nothing to do with the problem. I thought it was going to be related when I saw age 8, because there's a number in the word problem, but it's just unrelated. Like the formulas and the paragraph
so you can
have
just
nothing to do with each
remove the
other.
text completely, and
Yeah.
it's yeah, it
There,
makes
now it's a
sense.
math problem. What the fuck?
Yeah,
People
I
are like
was
so bored with math that they just start talking about pimps.
yeah, I was actually like walking, and I was thinking about like why they would have these problems, and I was like trying to think what reason there could be. So I was thinking like maybe you have like a story inside your math problems to like keep your students' interest or whatever. So I'm not like annoyed like oh my god I have to do so much math. But then I was thinking the problem with that is that this is like a sad story. Is this like supposed to be easy for someone to read? Is this supposed to like keep them encouraged to keep doing math? I was like, I don't think so. I think this is supposed to be like kind of a sad story that like maybe makes you sad. So, and I was
I
thinking
think
like,
I think it's supposed to be like a cliffhanger. Like you want to know what happens in the story, so you have to solve the math problem to find out what fills in the blank.
uh,
If you do the math, you get rewarded with finding out who abused Angelou, or which other profession the single mother had.
yeah,
I think they're
hey,
trying to imply that single mother pimps and prostitutes are not good enough at math to be bookies. They have to be nightclub dancers. On the other hand, she managed to be a pimp. That's not bad.
That's kind of confused by being a pimp and a prostitute. I'm not sure.
Yeah, maybe she started as a prostitute and learned the ropes, and then she helped the other prostitutes be prostitutes and became a pimp.
Hmm. Okay, the math. Uh, 3x plus 6y 6y equals 12. Okay, so this is the first problem. I don't need to worry about the second problem.
Right.
Yeah.
Yeah, one at a time.
Okay, so okay, so the thing he talked about was okay, I'm trying to remember. You need to know what substitution is, so whenever you see a x plus 2, you can just replace that with y. Wherever you see a y, you can replace it with an x plus 2. So like, oh yeah, and this means you have to multiply 6 by y, is that right?
Yeah.
And this means you have to multiply 3 by x.
Yes.
Okay.
When it doesn't say operation, that is multiplication.
Okay.
Oh, you typoed, by the way. Those are added in the middle.
Oh. Okay, so, oh, so, wait, this is just the x symbol. I was using asterisk to be multiplication. Okay, so y equals x plus 2, y equals x plus 2, 3x plus 6y, 3x plus 6y equals 12. Okay. Okay, so this is one equation where I have some information. This is another equation where I have some information. So I think you told me before that I need to use both of these to solve both of them. I can't just do one of them, right?
Yep.
Okay. Okay, so right here, plus 2 would be the same as 6 times. I'm gonna try making a tree. Would that do anything? I don't know, but I can try making a tree anyway.
Okay. That is not the standard thing, but yeah, you can play around, see if it helps.
Okay, so this is going to be a equals. Yeah, this is an equals, sure.
Yep. That is how the trees start.
Okay, so y and plus are the same, actually, and multiplication is, or the addition is an x and a 2.
Yep.
Okay, what's this one? Yeah, it's probably an equation. Okay, so we have an equation. We have it's a multiplication group actually. It's an implied multiplication group with a 3x. So I think I can just do this. Wait, did I do b instead of 3?
Yep.
Oh. Okay. And then oh hey, it's a group within a group, I think. The what's it called? Okay. The algebra, is that what it is? The letters are a number,
Uh-huh.
I think. And when you put them next to each other, that implies a multiplication, and that would
Uh-huh.
be a group. So it's hidden multiplication groups, although maybe not hidden.
Yeah.
But it's a multiplication group, and then it's you do the multiplications for the addition. So this adds. Right, this is equal. You have a. Okay, I think I'm doing. What do I want to do? I want a addition. Yes, addition. Okay. Okay, and then it's a 6 and a y. Okay, and it would be 12.
Yep, looks right.
Okay. Okay. Uh, yeah. Okay, did that do anything? Not that I can see immediately. Okay. Okay, so I know that x plus 2 is the same as y, and y is the same as x plus 2. So this, I know, would be 6 times x plus 2. Be
Yep.
the same as that.
Go make a copy and write that down.
Hmm. So you mean like, I guess I can try doing, uh, 6 times, uh, so instead of y I had a 6 times x plus 2.
Uh-huh.
So this equation is the same as this equation, I think. It equals the same. You can replace this one with this one, and it's the same.
They're both true, like the left side equals the right side.
Ah, okay.
They're
Equals.
not the same as each other, because the left side is different. They are both equal to 12, though, so they're the same in that sense.
Okay. Okay, so this is the left side, like 17 is the left side and 18 is the right side? Is that what we meant? Or-
No, the left side and right side refers to the sides of the equal sign.
Ah, okay. So like, 2 plus 1 equals 3 is different from 1 equals 3. So like both of these are true, but they're not the
Yep,
same.
they're similar but not the same.
Okay. But they're like sort of just as good as each other. You can like replace them and you can
Yep,
substitute them, and it's just as good.
yeah.
Okay.
So what you've done there is actually useful. The main goal when you're substituting is to get rid of a variable.
Oh, really?
Yes. If you can get rid of a variable, that is progress. And
Okay.
in
So if
your
I
new
were,
one, there are no y's anywhere to be seen.
oh, okay. So if I were to replace this 3 times x with a uh 3 times, okay. Wait, so what would y be? Okay, if I was to try to replace this x with a y, that would be bad. Oh, okay. So I think y would be x. Wait, so one's
And you got to replace x with x, not with y.
okay.
But
For
you
now,
don't
I'm
know what
trying.
x equals. You know what x plus 2 equals, but you don't know what regular x equals.
Yeah, I don't know right now. Okay, so I can't replace the regular x with the y if I don't know what it. So, is it impossible for me to replace? Or okay, can't be. I'm trying to figure
There's,
out how to replace this x with a y, even though I shouldn't, but I want to
you
see
can
how it
in several
works.
steps, but why don't you solve the problem first, and then I'll show you how to do that.
Okay. Uh, I'm gonna make another group and have this as a 3 times x.
Sure. Right, so you have an equation where you only have x's, which means that you can solve it. In order to solve it, what you want to get is x on one side and all by itself.
X on one side all by itself.
Yeah, and then some number on the other side, and then you'll know what number x equals.
Mm. Okay, I don't know
So
what it means to have x on one side.
one side of the equal sign. So
Okay.
if you had
So,
like x equals 13,
okay.
then you would have x all by itself on one side of the equation,
Mm-hmm.
and 13 a number on the other side. And then you would
Yeah.
know what x is. You'd be done. So
Okay.
that's the goal, is to get something that looks like that.
Okay, so. Mm, okay,
And
so.
because you only have x's with no y's, this is going to be possible.
Mm,
You only
okay.
have x's and numbers, and it is possible to sort them out.
X's numbers. Possible to sort them out. Okay, so it's possible to sort them out because I have an equal on one side, and then x is doing things on the other side. Okay. This
Yeah.
is
So the way you want to start is by doing your multiplication. You have 6 times x plus 2, and you can multiply that out.
okay. I have Hey, did you say I have 6 plus x times 2? Or okay, right here I think I have a
Yeah, that. 6 times the group x plus 2.
okay, 6 times a group x plus 2.
So, do you know how to multiply that and figure out what that equals?
Need to multiply that. What is that? This whole group I selected?
Yes.
Do I know how to multiply this? No. I mean, I guess I could try multiplying it by like multiplying it, but I don't know how to figure out what it equals.
Okay, do you know how to do, like 5 times 1 plus 2 without doing the addition first?
Hmm. No, I don't think so.
Okay, when you have a multiplication by an addition group, you
Hmm.
can multiply each of the things that's being added up together. So
Oh,
this equals 5 plus 10. You can
okay.
multiply
So,
the 5 with the first thing and the 5 with the second thing, and then you're done.
oh, okay. Uh,
Rather than first adding them to get 3 and then multiplying to get 15, you can also do it this other way.
hmm. Okay. I do not think I'm used to that. Okay. I have a so I have 6 x's and 6 2's. Say
Yup,
that would be hmm, maybe 6 2's is 12. I'm pretty sure. Is that right? 5 2's is 10. So 6. Wait, it's just 6 times 2, which is 12 because you multiplied 6 by 2.
yep,
Okay. And is there a way to say how many 6's I have in math without adding a parentheses? I have 6 x's. I guess it's just times 6. And then
yeah,
I can actually remove this, sort of. Uh,
yep. At this point, you actually don't need any of the parentheses.
uh,
Does that make sense?
okay. Uh, okay, so this is the multiplication group with the 3 and the x. Then this is the addition group with, like, yeah, it seems like these multiplications are kind of self-contained. Maybe it's, like, clear if I, like, remove the spaces in the multiplications. And then
Yep,
it's just uh, equation, or, like, multiplication plus number.
yep,
Why is this a plus 12? Was there supposed to be a plus 12 here? Oh, yes, there
yes,
was.
that is correct. Okay,
Because the.
so do you know how to add 3x plus 6x?
Okay, do I know how to add? This sounds like an immediate no, but I don't know if I do know.
Okay, do you know how to add 3 pizzas plus 6 pizzas?
Uh, I mean, you have 9 pizzas.
Yep.
Okay.
What about 3 things plus 6 things?
Oh, I think I get it now. I have 3 x's and I have 6 x's, so that would be 9 x's, right?
Yes.
Okay, so I can actually replace this. So this is 3 plus 6, and the numbers just happen to be x's,
Yep.
so that would be the same as a 9. Uh, hey, this looks like something that's
Oh, you lost your
solvable.
x.
Oh, right. Okay. Okay, messed up. And I thought it was just an instant solve. Okay, yeah, so you have 9 x's. Uh,
Okay, so there's another concept that's really useful. If 2 things equal each other, then you can do the same thing to both of them, and they will still equal each other.
okay, this seems like it makes sense to me. Let me try to make an example. Okay, so if we have a 6, and I'm just gonna have parentheses. Like,
You
if
can
we
just
have a
start with 6
6,
equals 6. Try that.
okay, so the parentheses. Okay,
Okay, so you can take both sides and add 1, and
okay,
then both sides will still equal each other.
okay. So, uh, 1, 1. Uh, okay, that looks right.
Yep, and you can do the actual addition, so you got like 7 equals 7, and also right. So this works with many operations. You could subtract 3 from both sides, and the sides will stay equal to each other.
Okay. Yeah, just making this into a 7. Okay, I wanted to try something with 1 plus 1, and 1 plus 1 is its own group, and then 2 as its own group.
Okay,
Yeah.
sure.
Alright. Okay. I don't know what happened, but that worked out.
Yeah, you don't need parentheses when it's the only thing, because the equal sign is always lowest priority. Like, you have parentheses around the entire left-hand side,
Mm-hmm.
but it doesn't do anything because it's the whole thing, basically.
Whole thing.
They're harmless,
Okay.
but the equal sign is always the last priority thing. Does that make sense?
Mm, I think so. It's like the last thing you do, it like separates 2 groups. I'm not
Yeah.
exactly sure.
Yeah, whatever's on the left is a group, and whatever's on the right is a group. So you'd never be like 1 equals 2, and then add 1 to that.
Yeah. It seems like you might be able to get into some sort of paradox if you're able to do that. I'm not sure.
Yeah, you would definitely be able to break things.
Okay. Mm. Okay, so if we divide both of those by 2, or if we divide everything in here by 2, then this would actually be like 0.5 plus 0.5, and then 2. I'm not sure if that's like actually how it's supposed to be, but
You can divide both sides by 2, and that should work out fine, because both sides will be half as big as before, they will still equal each other.
okay. But if you did something with like 10 times 10 equaling 100, then you divide each of the individual tens by 2 to get them to 5. Then you divide the 100 by uh, 2 to get it to 50. Then it would be 5 times 5 equals 50, which would be wrong. So when
Right,
it's the
so there was a
addition,
mistake there.
yeah,
What you have to
because
do is add it to the entire side, or divide it, or whatever. So you can put the whole side that's already there in parentheses, and then put your divided by 2.
yeah, so you divide the group.
Yeah. Whatever the
instead of...
left-hand side as a whole is gets divided by 2. And same thing for the right-hand side.
Okay, this makes sense.
People get really confused by this.
Okay. I think that's why I added parentheses at first, because I was
Yeah,
trying to
you
do...
need them once you divide.
Okay.
But you didn't need them before you divided originally. I didn't know you were planning ahead.
Yeah, at first I wanted to do something like multiple numbers, then you're like, start with 6, which is simpler. Wait, so was I doing a... I don't know how much credit I'm giving myself, and if I'm trying to take more credit than I deserve, I don't know. Okay. So 2 equals 2. This is true. So we have this group. I'm making it a group again. We have this group of that equals 2. This group that equals 2. Then... Okay, so this group equals 2. That is equal to 2. Okay, this is getting weird.
That's fine, you have 3 things and they're all equal.
Okay. I'm using this to indicate that this group is the same as a 2. But I'm using this to indicate that this group is a... I guess I'm using this to indicate this is... Yeah, okay. Then if we divide those by 2, would instead equal 1. So like, this equals is sort of a representation of what this group is, and then this equals shows that this group is the same as a 2. Yeah, it's just it looks a bit redundant, but it works out, I guess.
Yep, so you can divide both sides by 2.
So then, okay, so divide this
Or if you have 3 sides, you have to divide all of them by 2.
equal 1. And then I have to put this down to 0.5, I think. I don't exactly know. Like, if I want the addition. I could also do like 1. I guess there are multiple right answers. Okay, so there I was able to divide each individual number because it was an addition. But if it was a multiplication, then I don't think that would have worked. So now I'm going to do, say 2 times 2 equals 4. Yeah, okay, that works out. Do equals 4 equals 4. Okay, and then actually I should probably just do it like this for now. Okay, and then if we divide that by 2, so we divide by 2. Then if you just do that, it works because you're taking out a 2. But I don't know if there's like another way to do this that I was supposed to do that I'm forgetting about. Is there something I should do? I feel like I forgot something, but I think this
That
mathematically
turned
works
out
out.
right.
Okay.
Okay, so I did a couple to show you.
Okay.
Do these make sense?
Okay, so 1 plus 2 equals 3. That makes sense to me. Okay, the 1 plus 2 as a group plus 4 equals 3, which was like sort of its group. So the 3 was its own group, plus 4. So that makes sense to me. Yeah. Okay, 1 plus 2 plus 4 is the same.
I got rid of the
Okay,
parentheses because
yeah.
they're all additions, and you can do additions in any order. When it's only additions. The order doesn't matter.
Yeah. Okay, so when you do division, And exponents, it does matter, but it doesn't actually matter for the multiplication. I don't know why.
Right.
Also with the subtraction matters. Okay, so addition doesn't. Subtraction does. Multiplication doesn't. Division does. But then you get to exponentiation does matter, and roots do matter. It's like for the first like 2 levels, like for the addition and the multiplication, like the one that like makes numbers bigger matters, or it doesn't matter what order it is for the one that makes numbers bigger, like the addition and the multiplication, and it does matter for the ones that make numbers smaller, like the subtraction and the division. Then when you get to the exponentiation level, it matters for both of them. Okay. Yeah, so 1 plus 2 equals 3. And then 1 plus 2 times 5 is the same as 3 times 5. Okay, this seems like it makes sense. 9 plus 10 is the same as. Okay, I'm kind of confused where the 5 plus 10 equals 3 times 5 came from, but that is in fact correct.
The 5 plus 10 came from multiplying the group 1 plus 2 by 5. When you're multiplying a group, you can multiply each member of the group when they're added. Also with subtraction.
Alright, you multiplied each member of the group. The 1 times 5 got to the 5, and the 2
Yeah.
times 5 got to
You
10.
did that with your division when you divided each member of the group to get the halves.
Oh. Huh. Yeah. Okay.
People get really confused because they're like, how come we only added the 4 once on the left? As in, we didn't take 1 and add 4 to it, and take 2 and also add 4 to it. But then when we multiplied, the 1 got multiplied by 5, and the 2 also got multiplied by 5. So why did we do 2 multiplications, but only 1 adding of 4?
Mm-hmm. I think I got confused by that just now. Because words are confusing, yes. But if I try to look at it, okay, if you do it one way, then I think that gets the wrong answer. Like if you have
Yep.
a 1 plus 1 equals 2, and then you add 4 to the individual 2, or if you add 2 to the individual 2, it becomes 4. Then if you add 2 to the 1 and the other one, then it becomes 6. Then that would be 6 equals 4, which would be wrong.
Yeah, so you can look at it mathematically. In terms of concepts, we're trying to take a group and make it 4 bigger. So to do that, we need to add 4 one time.
Mm-hmm. So we're adding the
Like,
4 to the group as a whole.
yeah. So
Okay.
that part should make sense. Like, if we want to move 4 to the right on the number line, then we have to add 4 one time. And that will move us 4 places to the right on the number line.
Okay, yeah,
However,
this makes sense.
when we're multiplying, if we want to make the group 5 times bigger than it used to be, we have to multiply every part of the group to be 5 times bigger, or the entire thing isn't going to end up 5 times bigger than before. So when we're adding 4 more than the group. When we're multiplying, we're trying to take the group and do something to the whole group, which is make it 5 times what it used to be. So another way to look at it is, what is 1 plus 2 times 5? It is adding up. Multiplying something means add it 5 times if you multiply by 5, right?
Yeah. So you could do the group 1 plus 2 5 times.
Yeah. So the 1 and the 2 both get involved all 5 times.
Yes. So you can simplify this into having, instead of a 1, or instead of 5 ones, you represent it as 5. That would be 5 ones, so I think.
Yep.
And instead of 5 twos, you have 10.
Yes.
Uh,
That is a valid simplification. You can also just have 5 threes and add them together, but grouping up the ones and finding that you have 5 and grouping up with the twos and finding you have 10 also works.
Okay. So we have the 1 plus 2 group 5 times. Wait, do we have... Yeah. Yes, we do. That would mean we have 5 ones and 5 twos. Okay.
Yeah, so another way to look at this, since we have 5 ones, is that means we have 5 times 1, and we have 5 twos, we have 5 times 2.
Yes.
Okay. So what we were mainly talking about was you can take an equation where two things equal each other, and then you can do an operation to both sides, both groups that are equal, such as
Yeah.
adding 1 or subtracting 5 or multiplying
Okay.
or dividing. It even
So,
works with exponents and roots. Because they're the same, if you do the same thing to them, they should stay the same.
so if we were to say subtract 12 from this and subtract 12 from this, they
Yep.
will both equal 0.
Well, the left-hand side won't equal 0, but the 12 will get zeroed out. I know what you meant.
Uh,
So try doing it. Subtract 12 from both sides.
okay, so so this by 12.
Just write minus 12 on it, on each side.
Minus 12 and 0. Well, if we have the plus 12 and minus 12, that basically negates the 12.
Yep.
So,
Okay, so now take that line and copy the whole thing, and then you can simplify it.
okay, so this is just 0. This is a 0, but I can simplify that by just removing the multiplication, or the addition, I mean.
Yeah, that's fine. If 9x equals 0, and you want to know what x equals.
Okay, so give me a second. So 9 times x means we have x 9 times. Okay?
Yep.
And so I mean, okay, so I know that this means it's gonna equal 0, but I'm trying to figure it out.
Yes, you can. It's not that hard to jump to the conclusion on this one.
Okay,
But
so when
what mathematical operation can you do to both sides next?
any?
Well, yes, there are many different things you could do, but which one would be useful?
What would be used? Like, what is the thing we're trying to do?
You want to get an equation that says x equals number, or number equals x. The order doesn't matter. So you have a single x, one x equals something. In other words,
Okay,
find out what x is.
so I think we could try to get rid of these things, this
The 9.
multiplications.
Yeah.
So I'm trying to think about dividing by 9 would make it like 1 times x, but then that would also be maybe dividing by wait, so that would be dividing by 0. I'm not sure how division in 0 works. It's kind of confusing.
You can't divide by 0, but here you'd be dividing by 9.
Okay, so we have. Okay, so I take this here. So 50 divided by 9. divided by 9.
Yep.
Okay, so how many
Dividing
times?
both sides by 9 should leave them still equal. Then you can copy paste that one.
Okay.
And then simplify.
Okay. So we take out, so this division by 9 can take out multiplication by 9. So it means we can like
Yeah,
just take
so
this out.
suppose that you have 9 pizzas and you divide it by 9. What does that mean?
And pieces. Okay. I'm trying to. I forget exactly how to think of division, but I tried to memorize it as there's like two types of division. There's like communist division, where you try to make everything equal. That's like kind of what I think of it as. And there's another type of division where you try to see how many times the thing on the right goes into the thing on the left.
Yeah,
So
so
communist division is trying to make everything equal, sort of, and then the other type of division, seeing how many times the thing on the right goes into the thing of the left.
yeah, so one way to look at it, if you're dividing by 9, then you're splitting it into 9 separate groups, which do have to be equal.
Mm-hmm.
So if you have 9 pizzas and you divide them into 9 groups, how many pizzas do you get per group?
9, because there's going to be one pizza per group. Oh, hey, per is defined as a division, I think, right? Is that something?
Yeah, you misspoke though. You said there would be 9 pizzas per group?
Oh, what was the original thing? I thought we were doing 9 divided by 9.
Yeah, so how many pizzas are we going to end up with in each group if we make 9 groups?
If we make 9 groups. And how many pizzas do we have?
9.
Oh, 9 pizzas, and 9 groups would be 1 pizza per group.
Yes.
Okay.
So 9x divided by 9 is 1x, or 1 pizza.
Okay, 9x divided by 9 is 1 p. Hmm? Okay.
Does that make sense?
I think so, but I had the idea that it was 0, so I feel like it should be equaling 0.
Oh, that's kind of like subtraction. 9 minus 9 is 0. But we're taking 9 pizzas, and
Okay.
we're giving them to 9 different kids, so each kid is going to get 1 pizza, not 0.
Okay. 9, that would equal 1?
1 pizza. 1x, 1
Okay, so
thing.
9 pizzas divided by 9 equals 1. This is true.
Equals 1x, or 1 pizza.
Oh, there's 1. Oh, it equals 1x.
Yeah,
Okay,
1 times
so when we
x.
define it as an x instead of a 1, that makes it easier. Okay, this
It
seems
equals
possible
1
now.
times x, and then 1 times x also equals x. Because multiplying by 1 doesn't matter.
Uh,
Make sense?
yeah, so we have, how many x's do we have? We have 1 with x. Okay, and you can ask like how many zeros do we have as well. You can be like, we have 9 zeros and we're dividing it among 9 people. Like, how many zeros? Wait, does that work? I don't know.
No, you can add a bunch of zeros when you're doing addition. You can add a bunch of 1s when you're doing multiplication. Okay, and then on the other side, we have 0 divided by 9. So we have 0 pizzas and 9 kids. How many pizzas does each kid get?
Okay, so if I try to do it by communist division, so we have nothing, and we're dividing it equally among 9 people, that would equal nothing.
Yep. Yep. So, final result, x equals 0.
Yeah, this looks right.
Okay, and now you can use that information to help you figure out what y is.
Hmm. Hmm. Okay, so uh, this path.
Now you can use either equation. You need one that has y in it. And then you'll be able to figure out what y is.
I guess this is a y. Okay, so I'm just gonna like say this one first because it seems easy.
Yep, that one will
Y
be easier.
equals 0 plus 2. You can simplify 0 plus 2 as 2, and we can have y equals 2.
Yep. Yeah,
Okay.
so you do substitution. X equals 0, so they're the same. So wherever you see an x, you can put a 0 instead.
Okay, so now if you
And you
go,
can also try it with the other one. Yep.
you can this, uh, easy. Yeah, okay. Uh, mhm. Okay, and then I don't know. I'm indenting more. I don't really have a very good principled way of indenting, but I'm
Doesn't
doing
matter.
it anyway. Okay, so instead of 0 plus something, we can just remove the 0 and the plus because, uh,
Yep. Yep. So that step is called simplifying. That is a common step where you find something that you can make simpler.
okay.
So then for next step, what do you want to do?
I'm gonna turn this into a thing. Okay. Um, and then, okay, I know this is 2, but I'm trying to figure out why I know this is 2. Okay, for somehow, if we divide, if we do 12 divided by 6, that's 2. I don't know if I did something like that.
Okay, so mathematically, you want to get y equals something, or
Um,
1y equals something.
we want y.
So we're trying to find out how much y is.
Okay, so we know that y times 2 is the same as a 12. Okay.
Y times 6, not 2.
Oh yeah. Y times 6 is 12. So if we divide both sides by 6, we'll get the a y equal. All right, we divide them both by 6 to remove the multiplication, and
Yep.
then okay, cool. Uh, uh, and then 6 is going to just be simplified into y. Okay, and then 12 divided by 6 is going to be simplified into 2. Okay, so here we have a y equals a 2, and then
Yes.
up here we have a, in the x path we have a uh, x equals 0 divided
Yes.
by
So,
9, which equals 0.
so now you have a solution. X is 0 and y is 2.
Okay, so that means Angelo was sexually abused by her mother's boyfriend at age
Yep.
8.
Apparently. Math can't lie.
I feel like I don't know Latin, but I think non sequitur means something like does not follow,
Yep.
and I don't. This feels like there's a non sequitur here. I don't exactly know why, but like it
Yep.
doesn't seem like
What do 0 and 2 have to do with boyfriend?
yeah. So is that a non sequitur?
Kinda, yeah. It is arbitrary. Okay, so there's a common pattern with this kind of problem where you end up with something like this equation. 2x plus 55 equals 455. In other words, some number of x's plus or minus some number equals some other number.
X's. Okay.
And there's a standard way you solve it. First, you subtract the number from both sides. So in this case, it'll be minus 55. And then second, you divide by the number of x's. And then you'll end up with 1x on the left side. Because first you got rid of the number, and then you got rid of the number multiplied by x.
Okay, so we can get rid of the 55 because if we move both sides to the left by 55 on the number line, we like subtract 55. They like both equal the same number. It's like theoretically they like both equal like 1000, say. And if we move them to the left by 55, then they'll equal the same number. So we can take out the 55 from both. And then they're multiplied by 2. So if we take out the multiplication by 2 on both sides by dividing by 2, then they'll move the same distance.
Yep. So what does
Okay.
x equal in this one?
I'm pretty sure it was 200 from looking at it.
Yep. So more generically, you could write it like this, where a, b, and c are numbers. So if you see this pattern, you would first subtract the b, and then you would divide by a, and then you would know what x is by itself.
Okay, I'm kind of confused.
If you have some
Okay.
number of x's plus some number equals some other number, and you just want to know what x is in terms of all the other numbers, then you could subtract the b number, and then divide by the a number, and you would end up with x by itself
Let's check.
on the left. That will mean you get x equals something.
Okay, yeah, this sounds true. Wait, so is this like a common pattern that you see in these
Yes.
things?
Common pattern with these equations.
Oh, and by these equations, you mean like kind of school test equations?
Yeah, or just simple one variable equations.
Okay.
So when we subtract b, we're going to get ax equals c minus b. Then when we divide by a, we're going to get the group divided by a. Does that make sense?
Okay.
This is called solving for x, or in other words, trying to find out what x is, or in other words, getting 1x as one side of the equation.
Okay, so something times x plus b equals c, like the equation. Okay, so something times x plus b. And then something times x equals equation. Oh yeah, because wait. Okay, so we have ax plus b, so that's gonna be like the b is the 55. So if instead of adding b, we just don't add the b, then that basically moves it left by the amount of b. So if b is like 10, and then instead of adding the 10, we don't add the 10, that would mean it like moves to the left, like 10 on the number line. And
Yep.
then if we subtract the b from the c, it'll also move 10 to the left. So like instead of having to do ax plus b minus b, you just don't add the b to begin with.
Yep. Yeah, we can write it out with more steps.
No, no, copyright.
Does that make sense?
Yeah, if you divide it by the same thing. It doesn't even have to be like relevant. Like we could find out what like h would equal, or we could divide them both by like h, whatever h would equal, and it would still
Yep.
work.
Yep. So the problems they gave you were on the easy side because that already has a variable isolated, like you have y equals something. sometimes you'll get problems that look more complicated, and what you have to do is you'll get like, I don't know, 55x plus 3y equals 10, and then the other equation will be 3x plus 6y equals 12 equal. There. So if you want to solve this, what you need to do in order to do your substitution is get one of the equations into the form x equals something or y equals something, and then you can do your substitution into one of the equations. Does that make sense?
Okay, we need to get the y equaling something. So like here we got it so that
Yeah, x
x
or y. You
equals,
can take your pick. It doesn't matter.
and so here we managed to get an x or a y is the same as an x plus 2. Then we were able to use that on this x path, I think.
Yep.
Uh,
So in this case, I would take this one, and I would subtract 6y from both sides. Following the pattern, we have some amount of x's plus something equals something. So I'm going to subtract the 6y part and subtract the thing that's being added. We're going to get 3x equals 12 minus 6y. Following the same pattern we were just doing, and then we're going to divide by the thing that's multiplying x. So we'll get x equals 12 minus 6y divided by 3. Now we know what x equals, and then we can do a substitution, so we can take this, and we can substitute, and put this thing into it. And now we have an equation that only has y's in it, and then we can solve this for y, and find out what y is. And once we get y by itself, the other side is going to be only a number, because there's no other variables.
okay, I didn't fully follow through on that
That's
because I was
okay.
confused by or letters. Yeah, the letters.
Oh, do you have any
Not used
questions?
to letters. Do you have any question? No, I feel like the way I didn't follow is I'm not used to using letters. Although if you
Okay,
just use numbers, I probably still wouldn't follow it, I guess.
you can
So
do the next practice problem soon. I'll just go through this really quickly, because maybe you'll pick up a little bit.
okay,
So this one, I'm going to need to simplify the left term, because it is messy.
okay, simplify the left term.
So we have, all right, we're going to do the divide by 3. So the 12 will become a 4, and the 2y, or the 6y will become a 2y.
6.
And now I'm going to do the multiply by 55. So 55 times 4 is 220, and 55 times 2y is 110y. Now I'm going to take the 110y and the 3y and combine those. So we got negative 107y. Now I'm going to put the 220 on the other side over with the 10, so I'm going to subtract 220 from both sides. So 220 goes away, and we have 10 minus 220. And then I will do that and find out it is negative 210. Now I'm going to multiply both sides by negative 1. So I will get positive 107y equals 210. And then I would divide both sides by 107, so y equals 210 divide 107. So if you got the rough idea, it's fine.
Okay. Not sure if I.
So each of the individual steps is reasonably simple. I did steps like simplifying, or
Mhm.
adding something to both sides, or multiplying something by both sides, or subtracting from both sides.
So, on the last paragraph with 2 lines, I was confused why it seems like there's a 6 times y. So, last paragraph.
Oh, here. Yep. I did the division by 3. I did this part right here.
Division by 3. Okay, so I wasn't sure why you didn't divide by 6. Uh,
Because there's a
I didn't.
slash and a 3 means divide by 3.
Say. Yeah, but why not divide by 6 to get the 6y to be
Well, I'd have to
why?
divide the entire side by 6. And then I would have like 55 times blah 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 plus 3y, and then all of that divided by 6. The divide by 6 won't go on that little thing in the middle.
6.
Plus there's 2 different y's. So they're not even combined yet.
Uh,
So I needed to go through some of the arithmetic first and get rid of it. So I was doing simplifying steps. Because we have this divide by 3, and I can just do that. I can find out what that equals.
okay.
So I divided by 3, and my 12 minus 6y became 4 minus 2y when I divided by 3.
Hmm.
And then it was telling me that I have to multiply that with 55. So I was just taking this group here, and in a couple steps I was finding out what it equals, because this group was too complicated.
Okay.
It had multiple maths in it.
Right, so you divided the left group, but you didn't divide the right group, like the 10, or...
So I wasn't
I'm a bit
dividing both
confused.
sides by anything. I was only working with this one term here.
Okay,
And this term is...
this one too.
So if we just take this one term by itself,
Yes.
can you figure out what this equals?
Um,
Do it yourself in Atom.
okay.
Paste it in chat.
Okay, so what does this thing equal?
So for this thing, I was just simplifying this by itself and finding out what it equaled, because it was not in simplest form. So the other parts of the equation weren't even relevant when I was doing this.
Okay, so I'm going to drink a water.
So the 55 before the parentheses means times 55. It's the same as when you write 55x, it means 55 times x.
Yeah, okay. Okay, so this is 12. Let's try. Take away. Okay. Okay, so this is not in simpler forms. We can make it simpler. Okay, so if we divide this thing, why are we dividing this? Okay, still don't understand why we're dividing this by 3,
Make
and
a
why
tree.
not this by. Okay, true. Okay, is it reading? There's a multiplication happening. Okay, there's a multiplication. Okay, and it involves a 55. Yep. And then it also involves a parentheses. So you can, yep, there's this 55 in this parentheses. Okay. And what's in this parentheses? Okay, in the parentheses, there's a parentheses. I think, yep, in the parentheses, there's a parentheses. And there's also a division. Wait, is this parentheses is along with this division? I think this parentheses is actually a child of this division. And this division has a 3. Okay, I think I did that.
Okay, and then what gets divided by 3?
Yes. This group, which is under this parentheses. This group is this parentheses. Okay, then what's this group? It's 12. Oh wait, so there's actually a multiplication in this group, and okay, so there's a minus. Okay, there's a minus. Involves a 12, and it involves a multiplication, which is 6 and y.
Yep.
Okay. Okay, so this parentheses like isn't actually an operation. It's just indicating that this is like a group that's a part of it. I guess I didn't know that
Yep.
when I was doing this, but I guess it works. Like you use this thing with like these. This is sort of
Yep.
just an indicator of what it is.
Yeah. I think it'll help to get rid of the extra stuff in the tree now.
Okay.
You can look at it as a normal tree.
Okay. Okay, so I think that's everything.
Yep. So if you want to solve this, what would you do?
I guess. Okay, so I feel like I'm supposed to start from the bottom, but then also I think, wait,
Yep.
I feel like the first thing I do is start from the bottom. And there's also something about being able to divide multiple groups at once if they equal each other. But does any of these equal each other? It doesn't seem like there's an equal sign, so I'm not sure that they actually equal each other, any of these. So I don't think I can do the same operation on everyone. Okay. Okay, so this is 6 times y. So that could instead be called, say, oh no. Okay, so instead of 6y, we could have, wait, we could have y6. Wait. Okay, so that's already think. So this is 6y's. Okay, this
Yep.
equals 6y's. Okay, yeah, that simplifies it a bit. I don't know. 6 times 1? I don't feel like I
Okay.
made progress.
That's okay. Keep going. It doesn't
Okay.
matter if you call it 6 times y or just 6y. Once people are used to it a lot, they leave out the times because it's shorter, but it really doesn't matter either way.
Okay. Mm. Uh, 12. Okay, so we have 12, and we take out 6y from 12.
Mm-hmm.
So, uh, I mean, I guess you could write that as 12 minus 6 times y.
Yep. So then the question is that the simplest form, or can you simplify it more?
Can you simplify it more? Okay, so if this was a 1 and this was a 6, would that work? If you, wait, what does it mean? What is it? Okay, so if we divide both of these by 6, doesn't that make it simpler?
That would be simpler, but it would also be a different number.
Oh.
Because if you divide by 6, then you're going to have 6 times less. So you can divide both sides by 6 when you have an equation, but you don't have an equation here.
Okay.
So the answer is it is simplest form. There's nothing more you can do to it.
Okay.
There's no way to combine them that is particularly better.
So if this is like a...
So you can keep going.
Okay. So if this division thing was like a... that, okay, we can keep going. Okay. Divided by 3. Okay.
Yep, so
Well,
go
I
to the
guess
division node, and what does it equal?
it would be this. This.
Yes, that is correct. And then is that simplest form?
Okay. I think so.
It is not. You can divide the 3. You can take the group and divide it by 3. So
Okay.
suppose that you have 12 marbles minus 6 pizzas. 12 marbles plus negative 6 pizzas. And you have 3 kids. How many marbles and pizzas does each kid get?
12 marbles, 6 pieces.
It's the same numbers as you're looking at. 12 marbles and negative 6 pizzas.
12, 6, 3. They get the 2 of the pizzas and 4 of the marbles.
Yep, except the pizzas are negative, so they're going to get negative 2 pizzas.
Okay, so they're in pizza debt now.
Yes. Okay, so after the divide by 3, you can write another equal sign, and then you can write out what you got.
So, okay, after you divide. So,
On that note, on the far right, you can put another equal sign, and then you can put your simplified form.
wait, so am I writing on the tree?
Yeah.
Okay. Alright, so like another node like this.
No, in the same node.
Okay.
Right there.
Okay, like this.
Yeah.
Or
So you're trying to simplify it, so you're finding out what is the same as it. You're going to write something else that is equal to the same amount.
okay, so if instead of this number divided. Okay, so instead of trying to divide it by 3, we just instead of saying that we divide it by 3, if we divide it by 3, it will be simpler.
Yes.
Okay, and if we divide both things by 3, I think they will stay the same. If we multiplied them both by 3, oh, they'd actually still both stay the same. They'd be like at the same ratio. This is like a division. Wait. Okay, so if
They
you're
don't
doing
stay
like
the same. We're changing it because we're dividing by 3. We're going to get a lower number.
I was thinking like if you have 2 divided by 4, if you divide both sides by 2, it's at like the same ratio, right?
You mean divide the top and the bottom?
Uh,
2 divided by
yeah.
4 didn't have sides.
Oh.
Yeah.
I was thinking 2 divided by 4 would have sides because you have the 2 on the left and the division symbol in the middle and the 4 on the right.
Oh. Yeah, the sides thing is mostly used for equal signs.
Oh.
Also, fractions are typically written with a top and a bottom instead of on one line.
Okay, so if you divide the top and the bottom by the same number, then the ratio stays the same, so they would still equal
Anyway,
the
if
same
your
thing.
say your node was just 12 divided by 3.
Okay?
So how would you simplify that?
I could make it a 4 divided by 1, and then I
Yep.
could make that. Oh, it's 4 divided by 1. That's 4.
Yep.
So I could make it 4.
Yeah, so 12 divided by 3 equals 4. Then what if you have 12 minus 6y divided by 3 equals...
Okay. Uh, okay, on that one I've become confused.
Okay, well what if it is 12 marbles minus 6 pizzas divided by 3 kids equals...
Okay, I'm still confused.
How many marbles does each kid get?
4.
4 marbles. How many pizzas do they get?
2.
Minus 2 pizzas. And if you want, you can write per 1 kid.
Okay.
So if you get rid of the marbles and the kids, it's the same math. They're just adding them to make it more intuitive. But this version has doesn't have the marbles. Instead of pizzas, it has Y's. Doesn't matter. Instead of kids, it has 3's.
So pizzas has Y's. Instead of marbles, it's just
It's just
12.
numbers. 12 numbers.
Okay.
Or just 12. Yeah. 12 with no units. Anyway, so if you divide this group, 12 minus 6y by 3, so you're dividing this group into 3 equal groups.
3.
Division by 3 means divide it up into 3 groups that are the same size.
Okay, that makes sense.
Which is the same as dividing it up among 3 kids.
Okay, the thing I'm confused by with marbles, pizzas, and kids is that you have like 2 numbers.
Mm-hmm.
Yeah.
Right, so if you're dividing up 12 marbles and 6 pizzas, you just give them some number of marbles and some number of pizzas. It's the same thing here. We're dividing up 12, and also we're dividing up minus 6y. So how many numbers should the kids get, or the groups have?
They'd have 2 numbers per kid.
12 divided by 3 is 2? Not sure what you mean.
I was looking at the 4 marbles minus 2 pizzas, but minus 2 pizzas.
So if we have the number 12, and we're trying to divide it into 3 groups, we got...
4.
And if we have negative 6y, and we're dividing it into 3 groups, we got...
Okay, negative 3 groups. Negative 2, I think.
Like this?
Yeah.
What about the y's?
Negative. Oh, the y is a part of the 2's. It's negative 2 y's.
Yeah, so like this?
Yes.
Okay, so these things equal each other?
These. I'm trying to think about it.
Division by 3 means split it up into 3 groups, and then how much is in one of the groups. So also it is the opposite of multiplication. If we take this and we multiply by 3, will we get the original big group?
Yes.
Yep. So if these are equal, which one is simpler?
If they are equal, which one is simpler? The one on the right, I think.
Yeah.
It doesn't have the division.
Yep. So that is the simplifying I was doing earlier. I was doing the divide by 3. To get something with no division.
Okay. Yeah, okay. So divide it by 3. Okay. Okay, I'm still confused why we divide both of these.
We're trying to
Like
take the group 12y minus 6 has parentheses around it, so they're grouped
okay,
together.
12 minus 6. It's a group.
We're trying to take that group and divide it up into 3 equal portions. Because it says divide by 3.
Okay, if instead of a y was times 1, like does that work? Like the y could theoretically be times 1.
Sure.
Okay, and then just get rid of it now because it's redundant. Okay, so 20. Wait, so is this a minus? Is this a negative 6 or is it 12 minus 6.
Same thing.
Oh, it is.
Yeah. 12 minus 6 is the same as 12 plus negative 6.
I don't see how these would have been plus.
Adding negative 6 and subtracting are the same thing.
I agree with that, but I don't see how the 12 and the negative 6 would have been added.
Whenever you see subtraction, you can add the opposite.
Subtraction.
Instead of subtracting 6, you can add negative 6. It's the same thing.
Okay, so I agree with that. That makes sense to me. Instead of like going to the left 6 times in the number line, you can add going left 6 times in the number line. Or,
Yeah. Yeah, so whenever subtractions are, it's basically the same operation as addition in a different form. Whenever you see
so
subtractions, it's basically like additions.
I'm pretty sure
There's a
there are
way you
like
could put
some.
additions.
I'm pretty sure there's like maybe some programming languages where you don't have subtraction, you just have adding negative numbers. I feel like that's something I heard before.
Probably.
But I
It's,
don't see why these would ever be added. I don't know why there's a negative symbol here. Wait.
well, you can see it as a minus, or you can see it as adding the opposite. Like it's 12 minus 6y. It is a subtraction, but you can replace subtraction with adding a negative.
Oh, so this could be like this, or it could be uh, like this.
Yeah.
Oh, okay. Uh, oh. Okay, so if I called this negative 6, then I would have to like have an addition thing here. Like I was gonna
Yes.
call this negative 6. But if it was just like this, then I couldn't really call this a negative 6 without an
Yeah.
addition.
It is, that is 12 minus positive 6.
Yeah. Hey, you could do 12 minus negative 6 to add 12, I think.
Yep.
Uh, Okay, this is 12. And you take out the 6, or you have a negative 6 and you add it. Okay. Uh, okay. This is why. Uh,
So we were trying to solve this equation, and you were going through your tree, and you got here, which is all correct
uh-huh.
so far. And then the thing you want to do is simplify when possible. So it was possible to do the dividing the group into 3 groups.
Okay. Group into 3. This itself can't be simplified. So when we have the division by 3, it can be simplified. Uh, hmm. I feel like I'm supposed to make the 12 a 4 and the minus 6 minus 2. Then I don't really know why or what that would do.
Well, that's what division is. You divide it into 3 equal groups and see how much is in a group. That's what dividing by 3 is divided into 3 groups. So if you have this much stuff, 12 minus 6y, and then you divide it 3 ways, how much stuff do you have in one of the ways?
Can you say that again? No. It's
The
confused
amount
by
of stuff we have is 12 minus 6y, and we're trying to split it 3 ways.
Okay.
So if we split it 3 ways, and we get one of the ways ourselves, one of the groups, and our 2 buddies get the other 2, then how much do we have left?
We would have split it 3 ways. 2 people get the other thing. We get one of the things. Then we would have a 4 and a -2.
Y.
Uh,
No, I mean, you left out the y.
oh, okay. 4 and a -2y.
Yeah.
Right.
So that's what division means. That's literally what the division operator is.
Uh,
So that group divided by 3 equals the 4 and the -2y that you just said. The same way 9 divided by 3 equals 3. Or 6 divided by 3 equals 2.
I'm not sure what I'm confused at, or if I'm confused anymore, but I feel confused. So what? You divide. Uh, 1. Okay, if you have. Okay, so if you have a 4. Wait, I don't know if I'm confused anymore, but I feel confused. I think I'm supposed to find out if this is the simplest it can be. Divided by 3. We're only dividing the 6 by 3. It's not gonna affect the y. The y still stays the same. And
Wait, it's like if you have 6 pizzas and you divide that by 3, you got 2 pizzas. They're still whole pizzas.
okay. So if you have like a 10 minus 6, and you divide both of these, or okay, and you divide both of these by 2, that would be the same as 5 minus 3. I don't think so. Okay, so this is 2, and this is 4. Wait, is they supposed to be the same? This is supposed to be divided by that. It's not supposed to equal 12 point. It's not supposed to equal 12 minus 6. It's supposed to equal, if you take out the 3. Okay. So this did take out a factor of 2 from the final equation. Before this was a 4, now it's a 2. That means we took out one of the factors of 2.
Yeah, you did it right.
Okay. So, okay, and 10 minus 6 divided by 2 does in fact equal 5 minus 3. But if it was written like this, then that is wrong. Okay. Uh, so if we take out the factor of 3, I'm not sure why we're not dividing the y though.
You have to divide the two groups. The first group is 12, and the second group is 6y.
Okay. So if you have uh 3 times 1, like as a group.
Right, you wouldn't want to divide both the 3 and the 1. You just have to divide the whole group.
Okay. So you can just divide the 3 into a 1. And that works. Okay. Would equal. Okay. 2. Okay, I think that makes sense.
Okay, that is correct. And then, can you do the next node?
Uh, okay, so we have 55. Okay, so I think we have 55 fours and 55 negative twos.
Yep.
Okay. Uh,
Well, you didn't mention the y again, but
alright. Keep that much. 2y. 2 times. Uh, okay. So if I take uh, okay, that's 2 times 55. 2 times 50 is 100. Then 2 times 5 is 10. That'd be 110. And then the 4 is another factor of 2, then 2. So that
yep.
would be just 2 times more. So 220. Uh, okay, I think I did that right.
Yep, and that is the final answer. And you can't simplify that anymore.
Okay. Can you figure out what y is from this?
Nope.
Oh.
Nope. All you were doing was simplifying from this, uh, this.
Okay. Okay.
So if those equal each other, and one of them is simpler than the other one, that's all.
Okay.
You made it simpler without changing what the answer is, like how much it's worth.
Uh, okay. Okay, given that y could be any group of any size, I think that it's theoretically possible to have this equal any number and
Yep.
have y make that right.
Yes. Right. So you could say it equals 1, and then you could figure out what y is. Make that right.
So hey, you could maybe do uh, something like, oh wait, I was thinking like times 0 plus 1, but then with the other order of operations that might not work. But
Okay, so what do you want to do to both sides from here?
what do I want to do for
We were trying to find out what y is.
the... Oh, okay, so if I say that y is 1 and I'm trying to figure out what y is, I'm trying to figure out what y is. If I say
Yeah,
that that this equals 1.
yeah.
Hmm.
We decided it equals 1, so then what is y? So usually first you want to simplify things, but there's nothing you can simplify right now. So then you look at what you can do to both sides.
Do to both. So like I could. Okay, so by that you mean like I could multiply both sides by 10?
Yes.
Okay. So if you multiply both sides by 10, then I think this is what would happen.
Yes. Okay, and
Okay.
then what would be useful towards the goal of finding out what y is?
Hmm. Geez. Uh, maybe making it 0? Getting them down to 0?
Getting what down to 0?
Uh, the equals. I don't know what that would do.
No, so
Oh.
to find out what y is, you want to get an equation that looks like y equals and then a number. You want to get the y by itself. Does that make sense?
Oh. Okay. Think so. So like this one might end up being like negative if we like do that, but we'll get like y equals like negative like 157 or something. Like that
Yes.
could
It
happen.
might be negative.
Okay.
It might be negative, it might be 0, it might be positive. Doesn't really matter.
Uh. Okay. Both sides. Um. Well, okay. I'm gonna try looking up here and see if we did some. Okay. So we did a lot of simplifying. Then not sure how these would help.
What can you do to get rid of something that's near the y and get it away from the y?
Anything that's near the y, get away from the y. This multiplication thing, if we could like get rid of that, that'd be nice. Oh yeah, I should also be looking at this. I think. Wait, no, I want to be looking at this. Yeah, this is what I want to be looking at.
Yeah. The times 10 doesn't really matter. You can just keep going.
Uh, wait. So I can look at this.
Yeah.
Okay.
Or the bottom one. They're both fine.
Or the bottom. Uh, so this is a 110. If I could make that a 1, that'd be cool.
Yes.
So if I subtract, or if I can make it a 0, or okay, let's try to make it a 1. So if I subtracted 109 from both sides, does that make this a 1? Uh, okay, so am I allowed to subtract 109 from this? I think that's what I need to do. I think I can subtract from these three things. So I'll try that. Uh, so 109. I'm gonna use a calculator. Okay. 1 minus 109. Okay, negative 108. Okay, 100 for negative 110 minus 109. Okay, that went in the wrong direction. I want the minus 110 to be a positive 1. Okay, so that means we add 111. Okay, so this, you're going back to 1. Okay, so 1 add 111. That's just going to be, wait, what? Am I adding 111? Yeah, so I want to add 111 to both of them, which means the 1 is 112. Okay, so, okay, 112. Okay, 110, negative 110, 110, negative 110 plus 111 gets us to 1. Okay,
Hold
it's
on.
just,
So you have negative 110y.
okay, so this was supposed to be a plus. Okay, if I make this a plus thing, okay, I had negative 110y, so now it would be plus 1y.
Well,
Is that
you're adding y's and regular numbers together.
adding y's in
If you want to
regular
get to 1y, you'd have to add 111y.
get to 1y, 111 y's. So it would be,
It's like you had a negative 110 pizzas, but then you added marbles or something other than pizzas.
okay, so I think we have to do something with multiplication to get the y's to positive y's.
Yep, that would work.
Okay, so I'm gonna undo this. Yeah. Okay. So then, wait, did I mess something up? I don't know. Okay, this equals 1. I'm gonna move these further away. Okay, so I'm gonna multiply this by negative 1. I think that'll make it so you have a positive amount of y's.
Yep, that'll work.
Uh,
So you take both sides, and then you do times negative 1 on each side.
just 1 on 1 should get it to a
It'll
negative
help
1.
if you write out the steps, I think.
Okay. Times negative
Uh,
1.
I mean, so take the equation, and then write it again with a times negative 1 on each side.
Okay, take the equation, write it again.
What you wrote is fine, too. You can have both. But
okay. Negative 1 here. Then 1 times negative 1.
yeah, does that make sense?
Okay, multiplying this by negative 1, multiplying this by negative 1. I think so.
Yeah, so both sides are getting the same treatment. So now you can do a simplifying step.
Okay, so instead of multiply by negative 1, it's just negative 1.
Yeah, 1 times negative 1 equals...
Negative 1, I think.
Yes.
Okay. Then... I'm not sure how multiplying by a negative works here. I don't know if this turns into a negative and this turns into a positive number. I think that's what happens.
Yes. You multiply each thing in the group by negative 1, where thing means a term, or a thing being added or subtracted together.
And then I think we can do this. Sorry, this needs to be an addition. I think this works.
Yep.
I think we need the addition now.
Yeah, and then delete the negative 1.
Right.
You just used it. Okay, so that is correct.
Okay, now if we could divide it by 110, is that what I want to do? I think so, so that this is times 1y. If we divide it by 110, does that get us to times 1? I guess.
Yeah.
Okay. Uh, 10. I'm not sure how negative numbers work with division very well.
Same
There.
as multiplication.
Okay, I'm just gonna use a calculator for this part. Okay.
Okay.
0, 1. I don't a calculator. So you have a. What am I doing? I'm trying to divide something by 110. What am I trying to divide? Trying to divide this minus 1 by 110. Okay. Bye. Oh, okay, that's a weird number.
Yeah, you're not going to want to make that a decimal, just leave it alone as -1/110.
Okay.
Like, leave it as a fraction.
Okay. And then this. Okay. So we have.
Copy paste your line to another line before you edit it.
Alright, this one to another line.
Yeah.
Okay. And then we have 110. Bye bye. 110. Just 2, 1. Okay. And then I'm gonna see what happens when we do the. Okay, so I think we do the 2 to 0 divided as well. So I mean, it's probably just gonna. I didn't do the right one. Okay, so it's negative 0 divided by 10. Okay, that's just negative 2.
Uh-huh.
Uh, okay, we already did the divided by 100. Okay. Uh, okay, so instead of the 1 times y, I think we can just have a y.
Sure.
Um, okay, so y plus minus 2. I'm gonna do just minus 2. I think that works. It feels a bit simpler.
Sure.
Y minus 2 is the same as negative 1 of 110.
Yep.
I don't know if this is actually solved yet.
Nope, because you don't know what y is.
Uh, uh, hmm. Okay, so if we add 2 to this number, okay, so, does this work with the division there? I'll just have this as a group. 2, 2, okay. Instead of plus 2, it's just y.
Yep.
Then I don't know how this will work, but I'll try just. Okay, so we put in a negative 1,
Oh.
and we divide it by 110, and we add 2. Is it supposed to be approximately that number, I think?
Yeah, that's correct. What you have written out is correct as well. Decimal's not exactly simpler, it's just different. You can combine it into one fraction if you wanted to. It would be 219 110ths.
219.
But you don't need to worry about that.
Okay.
One thing people usually do differently, you did the dividing and multiplying first, and then the adding and subtracting.
Mm-hmm.
It's frequently done in the opposite order.
Oh.
Tends to be easier. So if you go back a few steps, you could have added 220 to both sides.
Oh. Mm,
And that is a little bit easier. But your way is also correct.
okay.
Okay, I'm
Okay,
gonna
so
go, but what you should do is find some practice problems and then do them tomorrow.
okay. Do
You did
them
a bunch of
tomorrow.
math today, but I would suggest you find some right now and then save them for tomorrow and then do them.
Okay, find some now. Yeah, let's find like more like kind of like this.
Yeah, you could try to do that one. Number
Yeah, like the
5.
second one.
We didn't do that yet. Yeah, so get that, but find some other ones as well,
Okay.
and then try to do them tomorrow, okay?
Do you know what this is called? Like two variables, two
It's
equations,
called a
solve
system
for
of linear equations.
a system of linear equations. Okay.
Yeah,
Uh,
system means there's more than one equation, and linear means there are no exponents or roots.
okay. System of linear. Let's find some
It
system
also means if you graph it, you will get a line,
graph.
which
Okay.
you don't need to worry about yet. But I was going to show you that. We didn't get to it, but see this line on this graph? This is the
Mm-hmm.
graph of y equals x plus 2, which we were dealing with earlier, and it graphs as this line right here. And I can explain what that means to you in the future.
Okay. It's something with graphs where on a like I think it's like on a linear graph, something looks like it moves exponentially. And if you put that on an exponential graph, it looks like it moves linearly. Is
Oh,
that a
yeah.
thing?
Yeah, something kind of like that. Yeah, that makes sense. Okay, so yeah, find some practice problems and then do some tomorrow. Okay?
Okay, I'm just gonna look up system of linear equation. Okay.
Okay, bye bye.
Right.